Hey, fourth graders, I'm back for another month of Number Corner. I'm so excited to be here, not only because I'm here with you, but also because we are going to be adding some new routines to our Number Corner. Do you think you're ready for that? I know I am. I hope you guys have had a great start to the school year, and I really hope you've been paying attention and working with me as we work through problems during our Number Corner. Because this month during Number Corner, you're going to have a quiz so that your teacher could see that you're learning the information that we're doing together. So if you haven't been participating, I encourage you to start participating. That means you're talking out loud, you're answering some of the questions that I'm going to be asking, and you may have your Number Corner journal in front of you or a piece of paper so that you can work through some of the problems with me. You may have noticed I keep saying work through problems. Well, that may be because today we have a problem string. That is our focus of today. I know you're familiar with problem strings by now because you've probably done some for your problems and investigations for bridges, and we did a few for our Number Corner in September. Today we're going to do another one. So it's not so new, but we will be incorporating something different than what we used the first time. So let me ask you this. What is the routine of a problem string? Yeah, in a problem string, we ask a series of questions that involve addition, subtraction, multiplication, or maybe even division. You're right. So I deliver them one at a time. Okay, that's important to know. But the big deal with problem strings is that you're supposed to use one of the previous problems to help you solve the next problem. That's our goal of problem strings, okay? We're going to talk about strategies for solving the problems, and hopefully that'll help you when you're solving problems during your math block or just in life in general. It's always fun to tell a friend, I know how to figure out this because I know this. My son tells me that all the time, and I just think it's a wonderful way to think about mathematics. Okay, so the earlier problems are going to be easier, generally speaking, and then they're going to get more difficult as we continue along. So remember, try to use some of the solutions or the strategies that we have solved to help you solve some of those more difficult problems, because there are connections between the problems. And hopefully you'll see that today. So we're going to get started. Here's our problem string for today. And I'm just going to give you a little context, because sometimes having a context when you're solving problems helps you think about it and visualize it a little bit better so you can make sense of what's happening. Here it is. We have modeling clay in the supply closet. You know, you may have used that in art class. It's sticks of clay, but it's in a box, and each box has 4 sticks of clay in it. So I'm going to wonder how many sticks of clay we have in however many boxes we have. So as we prepare to start this problem string, go ahead and open up your Number Corner journal to page, I want to say it starts at A1, and it'll look a little something like my screen as soon as I pull it up. And that way, you can work through problem strings with me. If A1 is full, guess what? Go to A2 or A3, because there are many pages in your Number Corner journal that you can use to work through some problems. So here we go. All right, do you have the paper that looks like this? I'll give you a few more seconds. If you need to pause the video, remember, you can do that as well. So our problem string today, we have a box of modeling clay with 4 sticks in each box, okay? So as I get started, I want you to go ahead and we're gonna create what may look like a T-chart, but we're gonna come to learn it by a different term before the end of our problem string. So I want one side to say boxes, and I want the other side, so I'm going to make boxes here, and I'm going to make it smaller this way. Okay, And I'm even going to put a line in between it just so I can separate the two that I'm working on. So here's my line. Make it as straight as I possibly can here. And on the other side, I'm going to put what we're talking about. What are we talking about? What's the context of this problem? Right, we have clay. I could even put sticks of clay, but I'll put sticks of clay. Sticks of clay. And I'm going to put that on the other side of what may look like a T-chart to you, but we're going to call it a different name pretty soon. Okay, so we have boxes and we have sticks of clay. I think now we're ready to start solving our problems. So here we go. First problem is, how many sticks of modeling clay are going to be in 2 boxes? How many are in 2 boxes? Let me just remind you, before we do 2 boxes, let's talk about how many are in 1 box. How many sticks are in 1 box of clay? Right, in 1 box, we said we had 4. So I'm going to put that here for you so you can remember. So as we continue through our problem string, that'll help you still figure out the answers to the next problems maybe. Right now we're looking for how many sticks of clay are in 2 boxes. So what's our equation? Maybe I should say, what's our expression? Do you remember that from last month, the difference? Right, 2 times 4 is the expression, and we now need to figure out the answer. And you should know 2 times 4, because we know anything times 2 is the other number doubled. So if I have 2 boxes, and in 1 box there's 4, that's 4 plus 4, 4 times 2, which gives me, you got it, 8. So in 2 boxes, in 1 box I have 4, in 2 boxes I have 8. And I probably need to put some more spaces in between here, just to keep it consistent. All right, now let's look at the next problem. Now I want to know how many sticks of modeling clay are in 4 boxes. Take a moment and work through this problem by yourself. Right, have you had some time? Okay, have you finished? I hope so. You probably already know 4 times 4, but I just want to remind you about something. When we're doing problem string, we're talking about strategies, and so we're going to use some earlier problems to help us solve the problems that are going to come up later on. So that means we're looking for relationships, the relationships between the numbers. So what I may do here is let me just add a box here that may help you in your thinking as we continue. What is really happening? What's the relationship between these 2 numbers when we're talking horizontal? Right, really I'm doing boxes, and I'm going to put a times symbol here, times 4, which is going to give me how many sticks of clay, okay? So that's kind of what's happening. Now, it looked like a T-chart, but we actually call this a ratio table. And as we continue, we'll talk a little bit more about how numbers are connected in a ratio table. So since we just solved, or you guys just solved 4 times 4, let's add it. What is 4 times 4? Right, it's 16. So I'm going to have 4 here, and then I'm going to add 16. You got it. Now, what if I were to ask you how these numbers are related? What would you say? How are they related? Let me give you a hint. When I'm talking about the relationship between the numbers, I'm looking at, we talked about the relationship between the numbers that are horizontal. So it's a box times 4 gives you the sticks of clay. So however many boxes times 4 is always going to tell you how many sticks of clay because of the context of this problem. But then we want to look at the relationship of the numbers that are going vertically. How are these numbers related? And I'm going to draw some arrows to kind of help us figure out the relationship. And maybe then you'll understand what I'm asking. So let's start with 2 and 4. If I'm talking in terms of, let's say, if I'm thinking multiplicatively, how is 2 and 4 related? So multiplicatively here, 1 and 4 related is because I said 1 times 4 gives you 4. So then 2 and 4 are related how? What times 2 gives you 4? Yeah. I did times 2. So maybe I need to write it like this. All right. So if I double this side, what do you think happens on this side? And if you're not sure, think about the relationship, the multiplicative relationship between 8 and 16. Right. I also multiply that by 2. So I'm going to draw another arrow like this. And I'm going to say I multiply that by 2 as well. Okay, is it starting to make a little more sense? Maybe? Okay, well, let's keep going. And as we keep going, maybe it'll make even more sense to you. So we're working with ratio tables. We have boxes that have clay in it. Each box has 4 pieces of clay. Our goal is to figure out how many total sticks of clay we have, depending on how many boxes we have. And the other goal is for us to use our knowledge of what's here on our ratio table to figure out what the answer may be. Okay, so let me show you the next one. 8 times 4. Well, how many sticks are going to be in 8 boxes? I'll give you a second to think about it and work through it in your journal. Anybody want to share their thinking out loud with this one? We have 8. Okay, what do you notice about? Or what is 8 times 4? Some of you probably already know this answer. What is it? 32. You got it. So 8 times 4 is 32. Did anybody think about the relationship between 4 and 8? I'm just trying to make this look a little more even here just so we can keep it consistent. What is the relationship between 4 and 8? Remember, we're thinking multiplicatively. You could think that we're adding 4 more boxes, which you're right. But you could also say that we doubled the amount of boxes that we had. Yeah, I'm doubling that side. So you may see or you may notice a pattern. I hope you notice a pattern. If you do, what is it? Yeah, so when you double the amount of boxes, you're doubling the sticks of clay. Right, so let's say that again. When you double the amount of boxes you have, you're going to double the sticks of clay. I could also think about it, when you double a product, you're doubling your answer as well. If you double, I could also say it like this. When you double one factor, then you're also going to double your product. Okay, let's continue. Now I want to know, how many sticks of modeling clay are in 7 boxes? Right, that's 7 times 4 because we know there are 4 sticks in each box. So I want you to think through how you may use your knowledge of what we've done here to help you figure out 7 times 4. Now, if you know 7 times 4, that's great, but that's not the question. The question is, what strategy can we use, knowing what we know here, to solve 7 times 4? So take a second and think about it. Okay, I need to hear some strategies. How are you going to use what we know here to solve 7 times 4. I didn't ask you, just tell me the answer to 7 times 4. What strategy could I use? And how is that going to work out in our ratio table? You're right, we can show arrows. But what are we going to show on those arrows this time? Are we doubling? No, you're right. We can't double 8 and get 7. That's silly. 7 is less than 8. So then what is the relationship between 8 and 7? We're talking about relationships here with ratio tables. If I were to put 7, pull this down, see where I am here. If I were to put 7, how does that relate to 8? Well, first of all, before we do that, no, let's stop there. How is 7 related to 8? Remember, we're going to think in terms of our context here. We have boxes of clay, okay? So in this problem, we had 8 boxes. So what's going on here? Yeah, we took a box away. So instead of having 8 boxes, now we have 7. Or, yeah. So how can I show that with arrows? What do I need to write? Okay, so 7, and the relationship we said was, okay, -1. And that's absolutely correct. So now we have 1 less box. So what's our arrow going to look like on this side? Well, what is 7 times 4? Be a little hint just in case you need it. Okay, 7 times 4 is 28. Okay, so 32 and 28, how are they related? Yeah, it's 4 less. Now let's think about, up here we talked about when you double a factor, you're doubling the product. In other words, if you double the amount of boxes you have, you're doubling the amount of sticks of clay that you have. But now we're saying we're taking a box away, and we're subtracting 4? Well, what does that even mean? Right, since we took 1 whole box away, and there are 4 pieces of clay in the box, and that means we got to take 4 away from the total that we had before. Good thinking. Guess what you just did? I'm going to throw a big word at you. Are you ready? Okay, here it goes. You unitized. You saw one group as 4. Way to go. You saw one group, I'm going to say it again, as 4. So in one box, which is one thing, it looks like one thing until you open up the box at least. Within that one thing, there are 4 things. Good job, you did it. 7 times 4 is indeed 28, which is 4 less than our 8 times 4 problem. Okay, let's look at the next one. How many sticks of modeling clay are now in 9 boxes? Remember, we're using what we know here to help us figure it out. So if you know 9 times 4, great. But then I'm challenging you to think about how is it related to something we've done here. 9 related to 2? Nah. Is it related to 4? Nah. We could make something up, or we could say 4 times 2 plus 1 or whatever. But our goal in mathematics is efficiency. So although I could say it's related to 1 because it's 1 times 9, or it's related to 2 because it's 4 times 2 plus 1, we want to be more efficient. We want to try to do less steps, okay? So did anybody say it's related to 8? Yeah, it's related to 8. It's kind of related to 7, I guess. You could say it's 2 more than 7, but let's come back to that thought. If you said it was related to 8, how so? I'm curious. Oh, so it's 1 more box than what you had before. So here, we're adding 1. Brilliant. Plus 1. Love it. Well, if you're adding one box, you had 32. Earlier we unitized. We knew that 1 really meant 4 because in one box we have 4 sticks of clay. So if you're adding a box, that means you're adding how many pieces of clay? Yeah, you're adding 4 pieces. So let me try to. So you didn't know 9 times 4. This is why we do ratio tables. This is why we talk through problems so that you guys can develop a deeper, a stronger sense of mathematics, which to me is very exciting. So I added 4, right? Right. Let's make that smaller so it can fit. So remember I said we were going to come back to the related to 7? Let's just talk about that real quick. You could say that 9 times 4, which we know is 36, is related to 7. You could say that because you could say, well, it's just 2 more boxes. And lucky for us, on our ratio table, we have the number 2. So in 2 boxes, there are 8. So if we wanted to say 7 plus 2 is 9, then we could say 30 or 28. Then we'd have to say 28 plus 8 would give us 36, which is also cool and would still be an efficient strategy to use. So that's fine. I chose 1 because it's really easy to add one group. Okay, let's do the next one. We're almost done. Ooh. We can do it. You know why? Because we have some things in our toolbox here with this ratio table that'll help us solve. 14 times 4. So how many sticks of modeling clay are in 14 boxes? You're going to have to think about it. Take a moment. Pause the video if you need. You can do it. I know you can. I don't know 14 times 4, but I know I can figure it out. Especially thinking about relationships in this ratio table. Does anybody see the relationship that they could use? You got it. Who else thought 7? You too? That's awesome. What do we know about doubling 7? When you double 7, you get 14. And we just talked about not long ago that when you double one factor, you essentially need to double the product. So you're doubling the amount of boxes. So that means you're doubling the amount of clay pieces that you have. So over 7, it was 28. So then let's double 28. And I hope you guys are able to keep track of my arrows here. 28 doubled. 20 plus 20, right? 40. 8 plus 8, right? 16. 40 plus 16, right? 56. You got it. So 14 boxes would give us 56. All right. Line it up here. I'm so proud of your hard work and dedication to figuring out these problems using our ratio tables. So here's the last one. And you're really going to have to think about it just like you've thought about these other ones. Are you ready? I hope so, because here it is. You can do it. 18 times 4. Use what we know. Go ahead and work it out. Who sees it? You got 18. How is it related to some of these numbers that are in our ratio table? Right, we could do 9 times 2. I'm going to stick with 9 times 2 because I really like the idea of doubling. Because I know, say it with me, when you double one factor, you double the product. So 9 times 4 was 36. So now I need to double 36. And if I double 36, what am I going to get? Yes, think about it. 30 plus 30. Yes, 60. 6 plus 6. Right, 12. 60 plus 12. You did it. I knew you could do it. See, I had all the confidence in you. So it is 72. Way to go. We completed our problem string. So now look at the problem string. Look at the ratio table and just see if you can make some observations. Yeah, you double a factor, you double the product. You double the amount of boxes, you double the amount of pieces of clay you have. But what else do you see here? We didn't just double today. Right. If you take one away, that's really taking away one group of 4 in this case, because one group has 4 sticks of clay. So you can take away one group, which is really taking away 4, or you can add one group, which is really adding 4. Thank you for participating with me today. I thought this was really fun, especially because it's a brand new month. It's fall, y'all. Great job today. I'll see you tomorrow. Have a good rest of your day. Bye.